Hello and welcome to Quick Maths with Mr. Johnson. In this video, I'll work out Cambridge IGCSE Mathematics Paper 1, that is non-calculator core paper, for the examination from 2025. In my last videos, I finished working all the way up to question 14. Now let us start question 15. A. As part of a sports competition, 14 athletes run 100 meters and complete a swimming race. The scatter diagram shows the times in seconds to run 100 meters and the times in seconds to complete the swimming race for 11 of these athletes. Here is the scatter diagram. Let's go to question. The table shows the times for 3 other athletes. Time to run 100 meters on top, swimming at the bottom. Question 1. On the scatter diagram, plot these 3 points. The first one is 10.20 seconds for 100 meters. That's right over here. The swimming race is 23.5 seconds. Now let me zoom in a little bit more and let's count the intervals from 23 to 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which means each interval represents 0.1. So 23.5 would be here. Okay. So 10.2 and 23.5 will meet over here. Zoom out. The second one is 10.86 and 25.4. So 10.86 and 25.4. Let me zoom in a little bit for 10.86. Let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is from 10.8 to 11. It is 0.2 and there are 10 divisions. So when we divide by 10, this becomes 0.02. So each interval represents 0.02 seconds. 10.86 and 25.4. 10.82, 10.84, 10.86. Here we have 10.86 and 25.4. So on the vertical axis, we know it is 0.1. So 25.1, 2, 3, 4. There we have 25.4. So let us go across all the way. Okay, and then let's go up all the way up. So this is the meeting point. Let's look at the third one, 11.04 and 24.9. 11.02, 11.04 and 24.9. 24.9 is right over here. So let's go up. Let's come across. So this is the point 11.04 and 24.9. Let us look at part 2. State the type of correlation shown in the scatter diagram. Correlation can be of 3 types. One is positive, the other one is negative, and one more we have, that is 0. Positive, if a line goes from left to right in the upward direction. Negative if it slopes downwards, and 0 if it is a horizontal line. Now if you think of the points on the scatter diagram, it is moving in an upward direction this way, so it has a positive correlation. Okay. Question number 3. On the scatter diagram, draw a line of best fit. Line of best fit may differ here and there, but we need to try and balance the number of points almost equal on either side of the line of best fit. You need to use your ruler and pencil. So I'm just drawing freehand, trying to draw this way. Okay. And then there I have the line of best fit. And then question 4 says, another athlete completes the swimming race in 23.8 seconds. Use your line of best fit to estimate the athlete's time to run 100 meters race. So let's go to 23.8 seconds in the swimming race. So let me zoom this little bit to make it more clear. We know every interval is 0.1, so 23.8 lies right over here. So let's come across all the way where it meets the line of best fit, and then let's come down. Here we have, so the estimate for the time, we know that every interval is 0.02. So if this is 10.2 plus 0.02 will give us 10.22 seconds. This may vary a little bit depending on where you draw the line of best fit. Okay, let's do part B. The table shows the diameter in centimeters and the mass in grams of 9 medals. Question 1. Write down the mode of the diameters. If you look at the diameters here, mode is the most repeated number. And if you look at the numbers very carefully, 70 is repeated 3 times. We have 85 2 times here, 60 and 60, but 70 is the most repeated. The mode is 70. The median of the masses. Let us put all the mass in order, because to find the median first we need to put them in order. The smallest one is 102, followed by 135, 152, and then we have 180, 181, this is 1, then we have 200, 231, then we have 412, and then we have 500. Now there are total 9, it is given over here. So 4 to the left and 4 to the right, 181 is in the middle, so 181 is the median. Question number 16. The line L is shown on the grid. Here we have line L. Question A. Find the equation of the line L in the form y equal to mx plus c. To find the equation, we need the gradient. Okay, to find the gradient, we can use the formula y2 minus y1 divided by x2 minus x1. But if you look at the line and the grid, you can easily find out by using the rule called rise over run. So here we have, let's take this point, okay, and then this is your rise exact across minus 1, and that's your run. So this is 2 units and this is 1. So gradient rise divided by run, that is 1 over 2, and it's a positive gradient. The line is sloping upwards from left, so half is our gradient. The form of the equation is y equal to mx plus c. So we found out m is the gradient. Okay, so we have half x plus c. This c over here is the y-intercept. Y-intercept means where is the line crossing the y-axis? That's minus 1. So y equal to half x minus 1 is the equation of the line L. The table shows some values for y equal to x square minus 2x minus 3. 1. Complete the table. So these are the empty spaces we need to complete. When x is minus 2, just substitute the value minus 2 in place of x. So y is going to be minus 2 squared minus 2 times x, which is minus 2, and then minus 3, and that will give you 4 plus 4 minus 3. This will give us 8 minus 3, and then the missing number is 5. Now when x is 1, so let me quickly write 1 minus 2 minus 3, and that is the same as 1 minus 5, and that's going to give us minus 4. And the third one, when x is 4, that's going to give us 4 squared minus 2 times 4 minus 3, that's 16, minus 8 minus 3, that's 8 minus 3, and the value of y is 5. Let's go to question number 2. On the grid, draw the graph of y is equal to x squared minus 2x minus 3 for x values from minus 2 to 4, which is already given in the table. All we need to do is plot these points on the grid. The first one is minus 2 and 5. Minus 2 on the x-axis, 5 on the y-axis. So here we have minus 2, 5. The next one is minus 1, 0. Minus 1, 0 lies over here. The next one is 0, minus 3, and 1, minus 4. 0 on the x-axis, minus 3 on the y-axis. And then the next one was 1, minus 4. So 1 on the x-axis, minus 4 on the y-axis over here. And the next is 2, minus 3, and 3, 0. 2 minus 3 is right over here, and 3, 0 is right over here. And the last one is 4, 5. 4 on the x-axis and 5 on the y-axis, and that's there. Now very carefully with your pencil you need to sketch the graph. Since I am using this tablet, it's not going to be as easy as on a paper. However, I'll try to sketch very slowly. So there we go. Now let's go back to the question part C. Write down the equation of the line of symmetry of the graph y equal to x squared minus 2x minus 3. Line of symmetry. Here we have the graph. This line over here is the line of symmetry. And what is the equation of this line? The vertical line, it crosses the axis at 1. So the equation is x equal to 1. And question D, write down the negative value of x where the line L and the graph of y equal to x squared minus 2x minus 3 intersect. Now, if you look at the point of intersection is right over here. For the line L and the quadratic graph, we need to write the negative value of x. And then if I go up all the way here I have this point, negative 0.7. Okay. So that's all for now. Thank you for watching. We will continue the rest of the questions in the next videos.